after we had our bit of funky disco inferno is that I'm going to do a couple of examples for you on those notes, and then you're going to have time during class to do big ideas. So it'll be another one of those things where I'm not on camera the whole time. Here's the agenda. We are going to finish filling out those notes because if you watched both videos yesterday, one of the notes was in the journal and then the other one was in just a plain, document that I made of notes for you to fill in. And then after that, you will be able to go over to 2.4 and finish big ideas. That's all. I'm hoping that you won't have homework, but anyway, let me go to the camera. And if you don't have those notes in front of you, please get them now. So I need to change to my camera. Again, as we're going, if you have any questions, raise your hand. Somehow let me know that you have questions. So I'm just going to start with that first page. And this is essentially an algebraic proof. So you've all done your first proof. For each one of these steps, we looked at those 7 different properties, which you actually already know how to do because you've all had algebra. So each time you do one of these steps, there's a reason for it, a justification on why you can do it. And that is subtraction, division, symmetric, all those kinds of things where those different reasons are now our reasons for geometry. And I didn't do the back page, but we did fill out this one. Okay, algebraic properties are used to isolate the variable on one side of the equation. And I just wanted to point out, if you didn't notice this already, on pages 51 and 52 are these properties that we talked about. So not only is it reflexive, symmetric, and transitive, there's also the distributive property, which is on the notes, and addition, subtraction, multiplication, division, and substitution. So, if for some reason you don't remember where the notes are, you took these yesterday with these examples. You can also look in the book on those pages. So this first one, some of you may have noticed, when I was doing this video, I wrote division, but I believe I said multiplication in the video. I apologize. I was very tired. 3 students in period 1 get extra credit because they pointed it out to me. They were very gentle about it too, which I liked. Okay, so what we're going to do is we're going to do these 2 examples, and then you'll be done with me for today. Again, if you have a question, raise your hand. But in the meantime, we're just going to try to go through this problem and justify. And I know you can all solve this problem. That's not what this exercise is for. This exercise is learning a process that is called proving it. You're going to prove things. And that's how we're going to justify. So the very first thing that you're always going to do is you're going to make 2 columns. And like I could do a little arrow here, a line. And over here is going to be the reasons. And the reasons are like the justification, okay? Over here is the work, and over here is the reason. We're calling this a statement, okay? Officially, these are our statements, and these are our reasons. So the first thing you do is write it down. And that reason is just given. This is the problem I am giving you. Here, it's a gift. Your problem. But what's the next thing we do? We look right above it. Yeah, we're going to distribute. So I'm going to draw my arrows because I always, if I don't draw my arrows, I sometimes get distracted, and then I make mistakes. So, and that turns into negative 35W minus 40 equals 30. And the reason we can do that is because of the distributive property of equality. You can go ahead and abbreviate, right? What's going to be our next step?
Plus 40 on both sides.
Right. Because I want to get W alone, and it's got this minus 40 with it, so I got to make that go away. Whatever's there, you just do the opposite. If you do it on one side, you have to do it to the other. So the next step you get is negative 35W. This, whoops, I made a mistake. You guys are supposed to tell me I made a mistake. Not 30. I don't want 30 to go away. I want 40 to go away. So I add 40 to both sides. Whoops. And that's the beauty of pencil and eraser too, by the way. Just erase it if you make a mistake. Or erasable pen works. But some of you scribble. Don't scribble, please. All right. So now this is gone, which is good. This is alone. I wanted that alone. But on here, this side, I now have 70. And so this is the additive property of equality. It says that I can add the same thing to both sides and I still get equality. Last, W is multiplied, and I want to undo multiplication by whatever is there. So I'm going to divide by that, so those will cancel. And that is the division property of equality. And then last I get what? W equals?
-2.
There you go, -2. Now, this is an example. I want to make sure that I'm correct because I made a mistake in there and I want to make sure I'm correct. So even mentally, all you do is you take that -2 and you're going to plug it in right here. I know it's kind of hard to see because I have the blue, but so 7 times -2 is -14 plus 8 would give me -6, and then -6 is multiplied times -5. So that is equal to 30. So not only am I correct, but I know I'm correct. So I give myself a happy face or a star or a check or whatever makes you happy. That way I know I'm good. Okay, any questions? Looking for hands up. And you all know how to do this. That's a beautiful part. That's why this is the practice part. This part, show me what you know. This part we're learning. And then next, now that we do algebra, next week we're going to do the same thing with like segments and triangles and angles and stuff. And it'll be the same stuff. There'll be problems you know how to do, and then we'll justify why we can do it. So solve the formula A equals 1/2 BH for B. Justify each step. Then find the base of a triangle whose area is. Now, when it says solve for B, solve for B. What that means is you want to get an answer of B equals everything else. You want B equals blah, 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 whatever B equals. And that's called isolating the variable. That's what those directions mean. So if I start with A equals 1/2 BH, my first reason is always given. That's my problem. But what am I going to do to get B alone? Like, what's one thing you could do? There's 2 things you can do. What's one thing you want to do? I either have to get rid of the half or the H. Well, both eventually. Pick one.
Times 2 on both sides.
Okay, so was that Megan? Thank you. She's saying times 2 on both sides. And that's a perfect thing to do because 2 times a half will give me 1 BH, and that's exactly what I want. You could divide by a half, but it's the same thing as multiplying by 2. So you just have to, whatever it takes to make whatever's there go away, that's what you have to do. So now on this side I have 2a, the half and the 2 cancel. Here I have BH, and my reason is the multiplicative property of equality. Okay, now B is multiplied times H. So to undo that multiplication, I have to do the opposite. Whatever's multiplying, you just divide it. And that is the division property of equality. So those cancel. Now I have 2a over h equals b, which is kind of nice, but at the same time, I don't want it to be this way. I want it to be this way. I want it to say b equals. So what property says that I can switch them and they're still equal? How can I flip those? Anyone have your notes in front of you?
Symmetric property.
That's correct. Symmetric is like looking in a mirror. So I can switch it, 3 equals 5, or 3 equals 3. Oh, that doesn't make sense. Anyway, you can switch them back and forth. Now that I have b equals everything else, I have solved for b. I've justified all the steps. So then it says find the base of a triangle. Oh, and by the way, this is how like scientists likes to do it. In engineering and in physics and chemistry and even biology, they like to do it this way, where all they have to do is now plug the numbers in. Just a heads up for those of you who are going to be engineers and chemists and things like that. I personally like to just plug them in where they're at, but this is called literal equations if you want more practice on it. But then it just becomes 2 times a is 952 feet squared, and the height is 56 feet. So when I multiply this times this and divide by that, I don't know what I get. What do I get? I can't do those numbers in my head, so I grab my handy dandy calculator and I do 2 times 952 divided by 56, and I get an answer of 34. So those are 34 feet, and that is B, which is a reasonable answer. So this is how, again, we just did a second algebraic proof. Any questions? All right, and now you have complete notes. Okay, go ahead.
So after we did this whole algebraic proof for the ending equation of b equals 2 times, do we have to like reason that too, if this was on the test?
So the way your test will work, this is a good question, you're always thinking about the test, is the first time I give you one of these in a quiz, I will give you exactly how many steps I want you to put in. So for instance, it's not 100% necessary, is it? This last step is not super necessary. So if I gave you a quiz with 3 blanks on this side and said, fill it in, then you know you would leave it there. But if I put in 4 blanks, then you would switch them. But ideally, I won't put anything in that's tricky like that.
Okay, thank you.
Okay, yeah, and you can always ask me, like I said. Other questions on the notes? Okay, now I'm not collecting your notes. They're for you. But like if I were you, I I've been taking these out and I've been putting them in my 3-ring binder so that my notes and my practice with 2.4 is all in the same place. And then when I go to BIM, when I go to Big Ideas, I have my notes and examples. I can keep them there all in one place. And that's what I want you to do also. Some of you like to use the class notebook, and that's fine too. I'm just really attached to my paper stuff. So what I'm going to do now then is basically dismiss you because you've done all your notes. We've done a couple of examples. You've had a chance to ask questions. Now all you need to do is do the problems and then turn them in. And then in a perfect world, so there's actually 30 minutes right now in class. So you should be able to get a very good head start on Big Ideas. And I'm just going to be hanging out here, as always, to answer any questions.